The majority of the time, raisins are eaten as snacks, but they are also a common item on many different cuisines. Raisins are dried grapes that are low in fat, high in dietary fiber, low glycemic index carbs, and high in minerals including copper and iron. In addition to having nutritional value, they also provide health benefits such as helping people with minor blood pressure increases by regulating their blood pressure. Raisins are typically significant commercial goods for the grape industry. The size, color, and grape variety all determine the sort of raisins. In this study, there are two types of raisins which have been classified, which are Besni and Kesima, with different methods. Machine learning methods or machine vision system such as logistic regression or LR, multi-layer perceptron, which is MLP, and SVM were used to classify raisins. The process that must be taken in order to classify raisins is from image acquisition, followed by image processing, feature extraction, classification, and performance evaluation. On the basis of machine vision, a raisin sorter has been created. An image of a raisin can be reliably segmented into desired, undesirable, and background regions using the algorithm segmentation technique given the straightforward manner. Why raisins must be classified? There are several raisin Besni and Kesima need to classify by using the three methods. By analyzing Besni and Kesima with logistic regression, multi-layer perceptron, and SVM, it is to know which are the method is the most appropriate to use for classify the raisins. Furthermore, it is to know which of the raisins with the most quality to send off to the market for producers and customers to choose the best raisins. The objective of this analysis are to determine the categorization models or algorithms to determine the level of three methods to classify the raisins. In order to fully understand the best quality for raisins, not in the terms of raisins color, cleanliness, softness or hardness of the raisins, moisture content of the raisins only, but with size of the raisins. This study applied the techniques or methods to classify the quality of raisins.
There are three formats in data preparation, which are CSV, ARFF, and Excel format. For data understanding, we have found that only 8 attributes for this project, which is area. It gives the number of pixels within the boundaries of the resin. Second, parameter. It measures the environment by calculating the distance between the boundaries of the resin and the pixel around it. Third, measure axis length. It gives the length of the main axis, which is the longest line that can be drawn on the resin. Fourth, minor axis length. It gives the length of the small axis, which is the shortest line that can be drawn on the resin. Fifth, eccentricity. It gives a measure of the eccentricity of the ellipse, which has the same moments as resin. Sixth, convex area. Give the number of pixels of the smallest convex shell of the region formed by the resin. 7. Give the ratio of the resin formed by the resin to the total pixel in the bounding box. Lastly, class, which is Kesmin and Besni resin. All of the data type for the attribute is nominal. During the process of feature extraction, a set of feature inference were carried out for each of the Kesmin, which is blue, and Besni is a red resin that could be seen on the image. A set of process of feature extraction consists of 7 morphological features with area, major axis length, minor axis length, eccentricity, convex area, extent, and perimeter. In overall, it can be seen that the mostly Besni resin is even larger than the Kesmin resin.
There are 900 resin records with 8 main attributes have been analyzed, and 3 classification methods were used to measure the accuracy of the dataset. There are 2 main groups of machine learning algorithms that work best with this data set, which are lazy group with IBK and K-star algorithm, and a meta group with randomizable algorithm. Based on the findings, the accuracy of the selected classified developed varies from 80.11% to 82.22%, which may be enhanced further by selecting the relevant characteristics. The high influential attributes were selected using the tools. The performance of these 3 algorithms in the dataset were evaluated using training data testing mode. After assessing the outcome of all algorithms, the greatest accuracy with comparable percentage was found in K-star, which is 82.22%, followed by IBK, which is 80.44%, and randomizable filter classifier 80.11%, as shown in the table and figure in the screen right now. Using the a priori algorithm, we want to find association rules that have minimum support equal to 0.1 and minimum confidence equal to 0.9. We may adjust the minimum support to 0.1 to produce a more frequent item collection. If we set minimum support as 0.2 or higher, we may eliminate many attributes, but the minimum number of attributes is insufficient to make a reasonable choice. However, minimum confidence 0.9 can be set higher because this limit might provide favor rules. Based on the result in the screen, the lowest support was 0.3, the metric confidence minimum was 0.9 and 14 cycles. As indicated in the table in the screen, we identify the optimal rules. The default setting for number of best rules for a priori algorithm is 10, and the results show the social coherence dominate with the higher number of best rules generated, which equal to 10 rules. In overall, it can be seen that the most important elements determining rising size are dominated by 3 best rules, which are perimeter, area, and major axis length.
For this dataset, we use 5 types of machine learning model. The model included are 0R, decision table, J-RIP, 1R, and part model. 0R is using class for building and using a 0R classifier. It will predict the mean for numeric class and mode for nominal class. As for decision table, it is using class for building and using a simple decision table majority classifier, which models that will result to different outcomes and accuracy. As for J-RIP, we are using the class to implement a propositional rule, which is repeated incremental pruning to produce error reduction or RIPA. Next, we move to 1R. We are using class for building and using a 1R classifier, which means use the minimum error attribute for prediction, discretizing numeric attributes. And last but not least, part model. It is class for generating a part decision list by applying separate and conquer. As for correctly classified instance, there are 50% for 0R, 81.44% for decision table, 82.11 for J-RIP, and 80.22 and 83.56 for both 1R and part respectively. Thus, it can be seen that the highest level of accuracy was part model, which is 83.56, 82.11 and 81.44 for J-RIP and decision table respectively.
Next, for decision tree, we use the J48 classification algorithm to classify and describe the result tree. There are 3 dimensions found, namely parameter, area, and major axis length of the 8 rules using the a priori algorithm. This is because they are the most influential dimensions. The most contribute dimension is the major axis length. It shows that 410 represent correctly classified events and 41 represent example correctly classified at height levels.
Hi, I'm Sabrina and I will explain about the relationship between major axis line and minor axis line. Major axis lines mean the length of the main axis, which is the longest line that can be drawn on the Raisin grain, while minor axis line is the length of the small axis, which is the shortest line that can be drawn on the Raisin grain. As illustrated in the figure, it is clear that most of Besni Raisin has smaller minor axis line and major axis line, the blue color consistently dominating, while the red one, which represent Casheman Raisin, are more sporadic. Some Casheman Raisin have longer mid-axis and line that can be drawn on the Raisin grain is longer, but some of them have shorter main axis and length of the small axis. It shown that major axis line can affect minor axis line, which means their relationship is linear. Now I will explain about the relationship between eccentricity and convex area. Eccentricity is a measure of the eccentricity of the ellipse, which have the same moments as Raisin, while convex area is the number of pixels of the smallest convex shell
of the region formed by the resin grain. Figure beside me shown the blue color, which represent a lot of catchment resins have high eccentricity but low convex area. Pesni resins, which are the red color, have high eccentricity too, but some of them have different value of convex area. It would be assumed that Pesni resin shape are more consistent than catchment resins as the pattern is around the same level. It could be said that the more eccentric resins are, the less convex area the resins have. Thank you.
Area means that gives the number of pixels within the boundaries of the resin, while perimeter is it measures the environment by calculating the distance between the boundaries of the resin and the pixels around it. Basically, resins is the red dots is the most gives the number of pixels within the boundaries in the measure the environment, while Casimir resin show the number of pixels in the lowest of measures of environment by calculating the distance between the boundaries of the resin. Extent means that gives the ratio of the region formed by the resin to the total pixels in the bounding box. Pesni resin the most give the measure of the eccentricity of the ellipse in the ratio of the region formed by the resin, while Casimir is the lowest give the measure of the eccentricity of the ellipse in the ratio of the region formed by the resin.
In conclusion, the main objective of this project is to measure resin, that is, to determine whether they are Pesni resin or Casimir. And the result of this study show that Pesni resin are the highest quality resin and the most accurate SVM machine technique to determine resin characteristic. Then, we have identified that this analysis has an optimal rule where the default setting for the best rule number for the appropriate algorithm is 10. The largest number is the best rule and is proven that only the major axis length has a big influence in the measurement of resin.
A priori algorithm was also used to find the association rule mining among all the attributes, and the best rules were also displayed. When coupled with other data mining approaches, developing classification algorithms in this manner assists in the construction of a more prediction tool. The future work will focus on improving the accuracy of the algorithm. The data may be extended to collect some of other resin's basic features and mine with different classification to predict the two different variety of the resins as future works. The authors are also interested in working in the future on data of resin features for different approaches, trying to know the difference of the resins. Enabling the speculative concepts and discussion continuously is vital to increase understanding of different features of resins. That's all from us. Thank you.